the chapter mechanical properties of fluid, and today we discuss the explanation of formation of drops and bubble. We know that the liquid drop and bubble are spherical in shape. The shape and size of liquid drop and bubble is spherical. This spherical shape of drop and bubble is spherical because the force of surface tension dominate the gravitational force. हे जे ड्रॉप्स आहेत आणि बबल आहेत हे आकाराने स्फेरिकल आहेत, भरीव स्फियर सारखे आहेत, सॉलिड स्फियर सारखे, कारण की तो सरफेस टेन्शनचा फोर्स आहे तो ग्रॅव्हिटेशनल फोर्सला चा विरोध करतो किंवा त्याला नाहीसा करतो. म्हणून काही वेळा आपल्याला हे ड्रॉप्स आणि बबल हे स्फेरिकल दिसतात. दुसरं कारण, in case of drop and bubble there is two pressure, inside pressure and outside pressure. The pressure inside the drop and pressure inside the bubble is slightly greater than outside pressure. Hence the drops and bubble have spherical in shape. Now we discuss the explanation of formation of drop. Now we consider the drop or spherical drop. Suppose this is the center and the R is the radius of drop. At point or center or inside that drop, the pressure is PR and the shape of drop. P0 is the outside pressure and Pi is the inside pressure, and this distance is suppose delta R, that is increase in radius. Delta R. Let the Pi is nothing but pressure inside the drop and P0 pressure outside the drop. The pressure inside, that is Pi, is greater than P0, that is pressure inside the drop is greater than pressure outside the drop. Hence the excess pressure, जास्तीचा pressure, excess pressure is Pi minus P0, and we calculate the extra or excess pressure, that is change in pressure, Pi minus P0, inside pressure minus outside pressure. Now in figure, let the radius of drop is increases R to R plus delta R. Due to pressure, the radius of this drop increases R to R plus delta R, where delta R is very, very small. Now we find out the area, initial area. Initial area, say A1 is 4 pi r square, and final area, this one is the initial area. A1 is equal to 4 pi r square, and final area of drop, say A2 is equal to 4 pi and increasing area r plus delta r. That is, this is the total area, is 4 pi into bracket r plus delta r square. Therefore, this increasing area 4 pi r square plus 2 r delta r plus delta r square. Therefore, A2 is equal to 4 pi r square plus 8 pi r into delta r plus 4 pi delta r square. But delta r is very small, its square is also very small, hence this bracket quantity is neglected. Therefore, final area A2 is 4 pi r square plus 8 pi r into delta r. I will find out the increase in area, and that increasing area, suppose dA increasing area is A2 minus A1. Therefore, dA is equal to value of A2, that is 4 pi r square plus 8 pi r into delta r minus 4 pi r square. Therefore, increasing area dA is equal to 8 pi r into delta r. This is the increasing area. Hence, the work done dW due to area dr is given by, or using relation between surface energy and surface tension, or work done and surface tension, dW is equal to T into dA. Therefore, dW is equal to T into values of dA, 8 pi r into dA. Say equation number 1. Work done, T is the surface tension of given drop or liquid, 8 pi r into dA. Now, according to definition of work done, dW is equal to force into displacement. But dW is equal to, this is the excess force into displacement is dr. Now we find out the excess force. The excess force can be determined from excess pressure. We know the relation between force and pressure. The pressure is equal to force per unit area. Now, we determine using a definition dW work done is equal to force into displacement. In our case, force is excess force and displacement is increasing radius, that is delta R. This is the small displacement. Now the excess force is given as, suppose, S, F, therefore dW is equal to F into dr. So delta R. Therefore, we find out this force is excess pressure into area. Therefore, F is equal to, because using definition of pressure, P is equal to F upon A, F is equal to P into A. Using this, force is equal to excess pressure into area. Therefore, F is equal to excess pressure Pi minus P0 into area 4 pi R square. Therefore, dW is equal to F, that is Pi minus P0 4 pi R square into dW. See equation number 2. We find out the work done, T into 8 pi R into dr, and according to definition, work done is equal to Pi minus P0 into 4 pi R square into dr. From equation 1 and 2, we can write Pi minus P0 4 pi R square dr is equal to T into 8 pi R into delta R. Delta R cancel, 1 R is cancel, pi cancel, 1, 4, 1, 2. We get Pi minus P0 into R is equal to 2 into T. Therefore, excess pressure Pi minus P0 is equal to 2T upon R. This equation, that is Pi minus P0, is nothing but excess pressure, which is equal to 2T upon R, where T is surface tension, R is radius. This is the excess pressure inside the trough. Now, in case of bubble, this equation is valid. Pi minus P0 is equal to 2T upon R in case of drop, but in case of bubble, bubble, the bubble has two surface area, inner and outer. Hence, the increase in area changes in case of bubble is 2 8 pi R into dr. Therefore, dA is equal to 16 pi R into dr, and work done is equal to 16 pi R into dr. This is the work done in case of bubble. Therefore, compare this work done with Pi minus P0 4 pi R square into dr, which is equal to 16 pi R into dr. Again, dr cancel, R cancel, pi cancel, 4 1 4 4. Therefore, Pi minus P0 into R, which is equal to 4 into T. Here T, dW is equal to T into dA. Therefore, dW is equal to T into dA. T into 16 pi R into dA. Therefore, Pi minus P0 into R is equal to 40. Therefore, Pi minus P0 is equal to 40 upon R. This is the excess pressure inside the bubble. This relation is valid in case of bubble. Excess pressure is Pi minus P0 is equal to 40 upon R, and Pi minus P0 is equal to T upon R in case of drop. This is the excess pressure or extra pressure in drop. This is extra pressure in bubble.